Azure Key Vault looks simple, a managed place to store secrets, keys, and certificates. But the defaults you pick on day one are the ones that page you at 3 in the morning or fail an audit 6 months later. In the next few minutes, I'll walk through the real decisions, what belongs in which object type, which access model to choose when a standard vault isn't enough, how your apps should authenticate, and how to handle rotation. These are trade-offs, not a feature tour, and pricing and limits change, so confirm against the current Azure docs before you commit. Key Vault stores 3 things, and using the wrong one creates pain. Secrets are arbitrary strings up to 25 kilobytes, connection strings, PII tokens, passwords. Keys are cryptographic key pairs you never extract. You send data to the vault for sign, verify, encrypt, or wrap operations, so the private key never leaves. Certificates are managed X.509 certs with a lifecycle, automatic renewal, and an integrated issuer. The rule of thumb: if your code needs the raw value, it's a secret. If it needs an operation performed without seeing the material, it's a key. Don't smuggle private keys in as secrets just because it's easier. The single most important decision is the access model. Legacy vaults use access policies, a flat list per vault granting coarse permission sets like get, list, and set. There's no inheritance, no deny, and the permissions don't show up in your normal Azure role assignments. The modern choice is Azure Role-Based Access Control, RBAC. It uses the same roles and assignments as the rest of Azure, supports inheritance from management group down to individual secret, integrates with privileged identity management, and is auditable in one place. My recommendation: choose RBAC for any new vault. Reserve access policies only for legacy systems you can't yet migrate. Next, how strong does key protection need to be? A standard vault is multi-tenant and software protected by default, with an option for keys backed by a shared Federal Information Processing Standard FIPS 140-2 Level 2 hardware security module. Azure Key Vault Managed HSM gives you a single-tenant, fully isolated pool validated to FIPS Level 3 with your own security domain. Managed HSM costs meaningfully more. You pay for dedicated capacity, not per operation. Choose it only when compliance, regulatory, or bring your own key requirements demand single-tenant Level 3 hardware. For the vast majority of workloads, a standard vault is the right and cheaper answer. Now the part people get wrong: how does your application read from the vault? Never store a vault credential in app settings. That just moves the secret problem. Instead, give your compute a managed identity and grant that identity an RBAC role like Key Vault Secrets user. The Azure Identity Library acquires tokens automatically with no secret in your code. For configuration, prefer Key Vault references in App Service or Azure App Configuration, or the Secret Store CSI driver in Azure Kubernetes Service, so secrets are injected and cached rather than fetched on every request. That also helps you stay under the vaults per second throttling limits. Static secrets that never expire are a liability. Set expiration dates and activation dates on every object so stale material is obvious. For supported resources, use event grid notifications on near-expiry events to trigger automated rotation through a function or logic app. Certificates can auto-renew when you use an integrated issuer. And turn on 2 safety nets that should be non-negotiable: soft delete, which is on by default with a retention window, and purge protection, which blocks permanent deletion until that window passes. Purge protection can't be disabled once enabled, so it genuinely stops an attacker or a bad script from wiping your keys. 2 more decisions. First, network access. A vault is internet reachable by default behind Azure Active Directory authentication. For sensitive workloads, restrict it with a firewall and a private endpoint so traffic stays on your virtual network. Second, vault layout. Don't dump everything into one giant vault. Use separate vaults per environment and per application boundary. This isolates blast radius, keeps RBAC assignments meaningful, and respects the per vault transaction limits, since one noisy app can throttle the whole vault. Treat vaults as cheap and disposable units of isolation, not as a single shared cabinet for the entire organization. Here's the framework to take away. Match the object type to how your code uses the material. Choose RBAC over access policies for every new vault. Stay on a standard vault unless compliance forces managed HSM authenticate with managed identity and cache secrets through references. Never embed a credential. Set expiry, automate rotation, and enable soft delete and purge protection. Then isolate with private endpoints and one vault per app and environment. If you do just one thing today, audit your existing vaults and switch them to RBAC with managed identity. And always confirm current limits and pricing in the Azure docs because these change. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.